In 2023, a team of physicists at Caltech made a discovery that shook the foundations of theoretical physics. They mathematically proved that stable wormholes could exist, but they also proved something far more disturbing. Traveling through one would create consequences so horrifying that it might be worse than being torn apart by a black hole. A wormhole could potentially take us to a distant star in seconds, allowing us to reach Proxima Centauri for breakfast and return to Earth for dinner, but the price might be something worse than death itself. Einstein called them bridges through space-time, tunnels connecting distant points in the universe like a cosmic shortcut. But unlike the clean, stable portals we see in science fiction, real wormholes would be governed by physics so extreme they challenge our fundamental understanding of reality. The first hurdle to creating a traversable wormhole is so enormous it seems insurmountable. The energy required to generate and stabilize a wormhole just 1 meter in diameter would exceed all the energy humanity has produced throughout its entire history, by a factor of at least 1,000. Imagine detonating every nuclear weapon ever created simultaneously, then multiplying that energy 1,000,000 times over. Even then, you wouldn't have enough. But this is just the beginning of our problems. The type of energy needed isn't just massive in quantity, it requires something that technically doesn't exist in our observable universe: negative energy or negative mass. While quantum fluctuations can produce tiny amounts of negative energy for nanoseconds, harnessing enough to stabilize a wormhole would require technology so advanced it borders on the impossible. The leading theories for creating traversable wormholes rely on exotic matter, substances with negative mass that respond to gravity by accelerating in the opposite direction. While theoretical, no confirmed exotic matter has ever been observed. Some scientists theorize that dark energy might have properties similar to exotic matter, but even if this is true, we have no method to collect or manipulate it. Physicist Kip Thorne, whose work inspired the film Interstellar, calculated that to create a stable wormhole, we would need to somehow harness matter with impossible physical properties, essentially requiring us to rewrite fundamental laws of physics. But let's assume we overcome these impossible energy requirements. Let's imagine we find a way to generate and stabilize a wormhole. What happens when we actually attempt to travel through it? This is where quantum mechanics enters the picture, and things get far more disturbing. Quantum physics tells us that at the microscopic level, particles exist in states of probability rather than defined positions. When these quantum effects scale up to the macroscopic level of a wormhole, the consequences become nightmarish. As you enter a wormhole, quantum superposition means you would exist in multiple states simultaneously. In practical terms, you wouldn't be one traveler moving through a tunnel, you'd be an infinite number of slightly different versions of yourself, all taking slightly different paths. This isn't just theoretical speculation, it's a mathematical certainty derived from our current understanding of quantum mechanics applied to space-time distortions. Imagine standing before 1,000,000 mirrors, but each reflection is making slightly different decisions than you. Now imagine those reflections aren't just images but actual versions of you, each experiencing a slightly different reality. This isn't science fiction. It's the unavoidable consequence of quantum mechanics in curved space-time. Physicists at Stanford University have calculated that quantum decoherence inside a wormhole would create a scenario where your consciousness could split into multiple streams, each experiencing a different outcome of the journey. The implications are philosophically terrifying. If you enter a wormhole, which you emerges on the other side, would you even be the same person who entered? Even more alarming is the precision required for successful wormhole travel. The mathematics show that even microscopic errors in wormhole geometry, errors too small to detect with any conceivable technology, could scatter your atoms across multiple points in space-time. Unlike a roller coaster where engineers can account for every variable, wormhole travel would require perfection at the Planck scale, the smallest possible unit of measurement in physics. A deviation of just 1 Planck length, about 1/100th of a millionth of a billionth of a billionth of a meter, could mean the difference between successful transit and having your atomic structure scattered across light years of space or even multiple timelines. The mathematics is unforgiving. Perfection would be required, and perfection is impossible. This leads to the consciousness-splitting paradox from quantum entanglement. When particles become entangled, the state of one instantly affects the other, regardless of distance. In wormhole travel, your atoms would become entangled with the fabric of the wormhole itself. Theoretical models suggest this would create a scenario where your consciousness might experience multiple outcomes simultaneously, including outcomes where your physical body is destroyed. Yet these quantum horrors pale compared to what awaits at the other end of a wormhole. The most disturbing question isn't about the journey itself, but about where or what these cosmic tunnels might connect to. The conventional assumption is that wormholes would connect 2 points within our universe, operating under the same physical laws. But recent theoretical work at Princeton's Institute for Advanced Study suggests something far more terrifying. Wormholes might naturally connect to places with fundamentally different physical laws, regions where the basic constants that allow life to exist could be radically different. Imagine emerging into a space where the electromagnetic force is stronger, instantly causing the electrons in your atoms to fly apart, or where gravity is billions of times more powerful, crushing you smaller than a grain of sand in microseconds. The physics on the other side could dissolve your atoms faster than a drop of water on the surface of the sun. Some cosmologists have proposed that wormholes might be connections between different universes within a larger multiverse, each with their own unique physical constants. If true, the odds of a wormhole randomly connecting to a universe with physical laws compatible with human survival would be infinitesimally small. The mathematics suggest that out of a hypothetical infinite number of possible destinations, perhaps only 1 in 10 to the power of 500 would allow a human to survive for even a second. Those are odds so low they cannot be meaningfully comprehended by the human mind. Even more disturbing is the predator hypothesis. First proposed by theoretical physicist Michio Kaku, it suggests that if wormholes exist naturally, they might have already been discovered and utilized by advanced civilizations. But rather than using them for peaceful exploration, such civilizations might weaponize them, creating what Kaku calls wormhole weapons that could target distant solar systems. A sufficiently advanced civilization could theoretically use a wormhole to deliver devastating energy pulses or even exotic matter capable of triggering stellar collapse, destroying entire planetary systems without warning. The terrifying implication is that if we succeed in creating a stable wormhole, we might inadvertently open a door that something else has been waiting behind. Cambridge physicist Stephen Hawking proposed that wormholes might connect to extra-dimensional spaces, regions beyond our three-dimensional perception where entities could exist with completely alien biology or even non-biological consciousness. Entities from such spaces would perceive our reality as primitively as we perceive a two-dimensional drawing. Their interaction with our universe through a wormhole could be catastrophic simply because the fundamental nature of their existence would be incompatible with ours. But the darkest secret about wormholes is one that physicists are only now beginning to understand, and it suggests something even more profound about the nature of our universe. What if the laws of physics themselves are actively preventing stable wormholes from being created? This isn't just speculation, it's a serious theory proposed by some of the world's leading physicists. Every time scientists develop a viable mathematical model for a traversable wormhole, they discover new physical principles that would cause it to collapse or become unstable. It's as if the universe has built-in safeguards against these cosmic shortcuts. Nobel Prize-winning physicist Frank Wilczek called this the self-censorship principle of the universe, the idea that physics itself might prevent certain technologies from ever being realized. The most alarming version of this theory involves vacuum decay. Our universe exists in what physicists call a false vacuum state, essentially a metastable configuration of quantum fields. Theoretical models suggest that manipulating space-time to the extreme degree required for wormhole creation might trigger a transition to a true vacuum state. This would create an expanding bubble of altered physics that would propagate outward at the speed of light, effectively destroying everything in its path. The universe as we know it would be erased and replaced with a new reality governed by different physical laws. Laws that would almost certainly be incompatible with life as we know it. This raises a profoundly disturbing question. What if previous civilizations have already tried? The mathematics of wormhole physics suggests that if stable wormholes were possible, evidence of their creation should be detectable throughout the cosmos. The fact that we observe no such evidence might not mean that wormholes are impossible. It might mean that every civilization that has attempted to create one has triggered its own destruction, or perhaps even the destruction of their entire corner of the universe. We might be alive precisely because no one has yet succeeded in creating a stable wormhole. Is our universe deliberately preventing us from creating wormholes to protect itself, or to protect us? The laws of physics might not just be descriptions of how the universe works, they might be boundaries that intelligent life is not meant to cross. Perhaps the greatest journey isn't across space but in understanding the fundamental laws that govern our existence and accepting the limitations they impose upon us. As we stand at the threshold of potentially revolutionary breakthroughs in theoretical physics, we must ask ourselves, if we could create a wormhole tomorrow, should we? The hidden dangers of wormhole travel aren't just matters of engineering challenges or energy requirements. They may be warning signs built into the very fabric of reality itself, cosmic guardrails preventing us from venturing down paths of no return. In our quest to conquer the stars, we might be overlooking the possibility that some doors are meant to remain closed.